Bismillah, Alhamdulillah, wassalatu wassalamu ala Rasulillah. This is the second lecture in section 11.2 about series. We studied uh, an infinite series, and we said that there is a sequence AN. We can call it the sequence of the terms of the series, and that the infinite series is the infinite sum of the sequence to infinity. And then we defined the partial sum sequence Sn. uh, and Sn is the nth partial sum, the sum of the first n terms. And we said that if this Sn, if this partial sum has a limit, if this sequence of partial sums has a limit, then the series is convergent to S. And we studied some kind of series called, which we can like this series, we can write it as a telescoping sum like this. And this series in which we can write as telescoping sum, we can find their Sn. And once we find their Sn, we can find the limits and show that they are convergent or divergent. Today we study another type of series called geometric series. And also geometric series, we will be able to find their Sn and determine whether they are converge or diverge. So this is the definition of a geometric series. It is A plus AR plus AR square. So in fact, the sequence here, the sequence of terms is AR, AR square. The nth term is AR to the power n minus 1, because here the first term was a to the power a times r to the power 0. So the nth term would be a to the power a times r to the power n minus 1. And it continues. This is an infinite sequence, a times r to the power n, and so on. But this is the nth term. Now, if we add the terms of the sequence, we get a geometric series. What is important here, each term, we obtain the next term by multiplying the previous term by r. So this is a times r multiplied by r, we get ar squared, then ar cubed, and so on. This r is called a common ratio, and we can find it by dividing any term by the previous term. So for example, if we divide ar, a times r to the power n over a times r to the power n minus 1, a cancels with a, and we get r to the power n minus n plus 1, or just r. Now, if we write Sn is the sum of the first n terms of this sequence, of the geometric sequence. So the nth term is a times r to the power n minus 1. If we multiply Sn by r, now the nth term, this nth term would be multiplied by r, and we will have a times r to the power n. Now if we subtract Sn minus r, Sn, we will get a, and ar will be cancelled with ar. And ar2 would be cancelled with ar2, and arn minus 1 would be cancelled with arn minus 1, and we will have a minus a times r to the power n. Now if we take Sn as a common factor from here, and a as a common factor from here, and if we solve for Sn, we will have this formula for Sn. So the sum of the first n terms of the geometric sequence can be found using this formula. And now we want to find out whether the series is convergent or divergent, so we find the limit of Sn. When we try to find the limit of Sn, when n goes to infinity, we will need to find the limit of Rn when n goes to infinity. And we know that this limit is 0 if r is between -1 and 1 in the previous section. So in fact, the limit of n, the limit of Sn when n goes to infinity, if r is between -1 and 1, so Rn, the limit of Rn would be 0, and the limit would be a over 1 minus r, under the condition that r is between -1 and 1. So if r is between -1 and 1, Sn has a limit, a number. A is the first term, r is the common ratio. Just divide the first term by 1 minus the common ratio, you get S. Then the geometric series is convergent only if absolute value of r is less than 1, which is the same as writing r between -1 and 1. So these two are the same. So if absolute value of r is less than 1, the geometric series would be convergent, and it converges to a to the power 1 minus r. So this is the sum of the geometric series if absolute value of r is less than 1. Otherwise, if absolute value of r is not less than 1, then the geometric series is divergent. So the sum of a convergent geometric series, the first term over 1 minus the common ratio. Some examples: find the sum of this geometric series. Well, it is a geometric series. The first term is 5. The common ratio, we can find the common ratio by dividing any term by the previous one. So -10 over 3 divided by 5, or multiplied by 1 over 5. So we get -2 over 3. Notice that absolute value of r is 2 over 3, and this is less than 1. So this series is convergent, the geometric series, and we can find the sum. The sum would be a, which is a over 1 minus r. A is 5, 1 minus r is -2 over 3. Okay, so 5 over 1 plus 2 over 3. The answer is 3. So this is the sum of this series. Is this series convergent or divergent? You can replace n by 1, find the first term and then the second term, and check the third term, the fourth. Check it is a geometric series first, because he did not say. And if it is a geometric series, find absolute value of r and determine whether it's convergent or divergent. I'll do the same, but I will compare it with the geometric series. We know that the geometric series, uh, this is important, can be written as summation a times r to the power n minus 1 from 1 to infinity. I can start by 0 in some exercises. You may find the geometric series starting from 0, and in this case, the nth term here would be written a times r to the power n. Okay, because if n is 0, I get a times 1, which is a, the first term. So pay attention, either we use this one or this one. So you look to this, the first value of n. Does it start from 1 or from 0? So here starts from 1. So I will try to compare this with a times r to the power n minus 1 from 1 to infinity. So I have 2 times 2 to the power 2n. I can write it 2 to the power 2 all to the power n, or 4 to the power n. And 4 to the power n, I can write it 4 times 4 to the power n minus 1 to get something to the power n minus 1. If you add the powers, you go back to 4 to the power n. 3 to the power 1 minus n, I can take it to the denominator and multiply the power by negative. So I get n minus 1. So in fact, summation 2 to the power 2n times 3 to the power 1 minus n can be written as 4 times 4 to the power n minus 1 over 3 to the power n minus 1. And this is 4 times 4 over 3 to the power n minus 1. And now it's exactly similar to this. So A is 4, R is 4 over 3, which is greater than 1. So this series is divergent. It's divergent geometric series. Some other type of examples write this number as a ratio of integers. These numbers can be written as geometric series as follows. To write it as a ratio of integers, this is a rational number. So prove that it's rational by writing it in terms of a over b, integer over integer. Make it a rational number. Okay, it is a rational number, but I mean write it in that form. So I can write it as 2.3. There is no repetition in the first part, 2.3. But this part, which is repeated 17, 17, 17, I can write it as the first number 17, put zeros. So instead of 3, put 0 and write 17. Now, if you add 2.3 plus 0.017, you will get 2.317. Try to write the second 17. Okay, the second 17, I write it by replacing all the previous decimals by zeros. So it's 0.00017. And the next 17 is 0.0000017, and so on. So I wrote this number like this. It is the same number. If you add the digits, if you add these numbers, you get back to this number. So now look to these terms. In fact, from here on, this is a geometric series where A is 0.17. This is the first term. And you can find R by dividing the second term, for example, by the first term or the other term. Okay. If you divide any terms, you will find that any term by the previous one, that this is in fact a geometric series with R equals 0.01. And this is less than 1. So it is a convergent geometric series. And the sum of this geometric series would be equal to A over 1 minus R. So the sum of all of these terms would be equal to 0.017 over 1 minus 0.01. And this is equal to 17 over 990. So in fact, 2.317 is repeated, is equal to 2.3, which can be written as 23 over 10 plus 17 over 990. And if you add these two, you can write this number as an integer over an integer, and you can prove that it is really a rational number. Some other examples about the same idea. So immediately I will write this as 0.8, the first, this one, plus 0.08, this is the second 8, and the third 8 is like this, and the fourth 8 is like this, and so on. So this is a geometric series with A equals to 0.8 and R equals point. If you divide 0.08 by 0.8, you get 0.1. So this is less than 1. So this is a convergent geometric series with sum equals A over 1 minus r, and it is just 8 over 9. So in fact, this number can be written in the form 8 over 9. And if you use the calculator and write 8 over 9 and press SD, you will get this number 0.8888 and so on. Also here I can do it similarly. I can start by 0.46, adding the second 0.46, then the next 446 and so on. So A is 0.46 and R, if you divide 0.0046 by 0.46, you will get 0.01. So this is R. So this sequence is convergent to A over 1 minus 0.01. And the answer would be 46 over 99. Determine whether the geometric series is convergent or divergent. Well, he said it's a geometric series. So A is 3, R is the second term over the first term. Well, absolute value of R here is 4 over 3, and it is greater than 1, not less than 1. So this is a divergent geometric series. Well, here A is 10 and R is negative 2 over 10. So absolute value of R is 2 over 10 or 1 over 5, and this is less than 1. So this is a convergent geometric series, and its sum would be 10 over 1 minus R, which is negative 2 over 10 or 1 over 5. So the answer would be 25 over 3. This series starts from 1 to infinity. So if I compare it with this series, the formula for the geometric series, I can notice that A is 12 and R is 0.73, and this is a number less than 1. So this is a convergent geometric series, and the sum is 12 over 1 minus R, which is 0.73. So the sum is 400 over 9. Well, I need to rewrite this series in the form A times R to the power n minus 1. Well, negative 3 has already power n minus 1, so 4 to the power n, I will write it 4 times 4 to the power n minus 1. So I will have 1 over 4, and then negative 3 to the power n minus 1 over 4 to the power n minus 1. I can write it negative 3 over 4 all to the power n minus 1. So comparing with this, A, the first term, is 1 over 4, and R is negative 3 over 4. Well, absolute value of R is less than 1, so it's a convergent geometric series, and the sum is A, which is 1 over 4 over 1 minus negative 3 over 4, which is R. So the answer is 1 over 7, the sum of the series. Here also it starts from 1, so I need to compare it with this definition of the geometric series. E to the power 2 n, I write it e to the power 2 all to the power n, and then I write it e to the power 2 to the power 1 times e to the power 2 to the power n minus 1. 6 to the power n minus 1 is okay. So this would be summation from 1 to infinity. I have e to the power 2, e to the power 2 to the power n minus 1. I can write it e to the power 2 over 6 all to the power n minus 1. Comparing, a is e square and r is e square e to the power 2 over 6. And if you use the calculator, this is greater than 1. So this series is divergent. Well, here I have 6, which is 3 times 2 times 2 to the power 2n minus 1 over 3 to the power n. Well, this 3, if I bring it down, it would be 3 to the power negative 1, and then multiply by 3 to the power n, I will have 3 to the power n minus 1. And the 2, I will have 2 to the power 2n minus 1 plus 1, so that's 2 to the power n. So I can write it 2 to the power 2 all to the power n, or 4 to the power n, and then I can write it 4 times 4 to the power n minus 1 over 3 to the power n minus 1, and then it can be written as 4 times 4 over 3 to the power n minus 1. Compare it with this form, I find that a is the first term is 4 and r is 4 over 3 and it's greater than 1. So this series is divergent geometric series. I will solve some more examples or questions about geometric series. Here x is 0.999, and to find out whether it's less than 1 or equal to 1, we write it as an integer over integer. We do like what we did in the similar exercises. We write it 0.9 plus 0.09 as a geometric series, 009 and so on. And this is a geometric series with a equals 9 and r equals zero point 0.1 if you divide 0.09 over zero point 0.9. So it is a convergent geometric series, r is less than 1, and the sum would be 9 over 1 minus zero point 0.1, and that's 9, a is 0.9, sorry, not 9. So it would be zero point 0.9 over zero point 0.9, which is 1. So in fact, x is equal to 1. It is not less than 1. So 1 has two representations. Either you write it 1.000 up to infinity, or you write it 0.9999 up to infinity. These two are the same exactly. If we look to this sequence, it has these terms. This is a recursive definition. He needs to find summation an when n goes from 1 to infinity. So let us try to understand this sequence. Let us try to find a2. a2 is 5 minus n. n is 2, so 5 minus 2, so that's 3 times an minus 1, which is the previous term. So if you have an here, the previous term. So this is a2, so here I have a1. 3 times a1 is 3 times 1, which is 3. So the second term in this sequence is 3. How to find the third term? Well, the third term would be 5 minus 3, which is 2, times the second term, the previous term. So it's 2 times 3, because the second term is 3, and the third term is 6. Trying to understand this sequence, this series. So let us find a sequence. It's a sequence, okay? Let us find the fourth term. The fourth term, 5 minus 4, that's 1, times a3, the previous term. So it's 1 times 6, so it's 6. Now what about a5, the fifth term, 5 minus 5? Oh, that's 0, times the previous term, which is a4. So it's 0 times 6, so it's 0. And now a6 would be 5 minus 6, which is negative 1, times a5. But a5 is 0, so a6 would be 0. And a7 would be written in terms of a6, and a8 would be written in terms of a7. So all the coming terms would be zeros. So actually this sequence is, the first term is 1, then the second term is 3, the third term is 6, the fourth term is 6, then the fifth term is 0, and the sixth term is 0, and all the other terms is 0. So the summation of an from 1 to infinity would be 1 plus 3 plus 6 plus 6 plus zeros, so it would be 16. Some kind of exercises: find the values of x for which the series converges. I need the values of x for which the series converges. Well, this series is called power series. We have x here. X is a variable. It could be positive, it could be negative, it could be zero, nothing mentioned about it. So for what values of x this series would be convergent? Well, I have 1 to infinity, I have number to the power n. X also could be a number, so why not comparing this with the geometric series a times r to the power n minus 1? Well, to write it in that form, I can write it first negative 5 times x to the power n, and then I can write it negative 5x to the power 1 times negative 5x to the power n minus 1. And by writing it in this form, it could be compared with the geometric series, in which a is negative 5x and r is also negative 5x. So comparing it with the geometric series, it would be convergent if absolute value of r is less than 1. So converges if under this condition. So r is negative 5 over x. So find the values of x that make this absolute value less than 1, and then you will answer the question, because the question says find the values of x for which the series is convergent. So to solve this inequality, I will distribute the absolute value on the product, and this is possible. Absolute value of negative 5 is 5, so I will have absolute value of x less than 1 over 5, because absolute value of negative 5 is 5. And I have a formula that says if you have absolute value of x less than d, this means that x is between negative d and d. So this means that x here is between negative 1 over 5 and 1 over 5. And these are the values of x that make this series convergent. So this is the answer of this part. Well, there is another part. Find the sum of the series for those values. Well, for those values, the sum would be a, which is negative 5x, over 1 minus r, which is negative 5x. So the sum would be negative 5x over 1 plus 5x for these values only, because this series is convergent only for these values of x. Similar question. Well, here n starts from 0. So I compare it with this form of the geometric series. So I can write this as x minus 2 over 3 all to the power n. And I can see by comparing that a is 1 and r is x minus 2 over 3. And it's a geometric series, so it's convergent geometric series only if absolute value of r is less than 1, or absolute value of x minus 2 over 3 is less than 1. Well, distributing the absolute value, I have absolute value of x minus 2 over absolute value of 3, which is 3. Multiplying by 3, I have absolute value of x minus 2 is less than 3 using the definition. So x minus 2 is between negative 3 and 3. Adding 2 to all sides, negative 3 plus 2 is negative 1. 3 plus 2 is 5. So these are the values of x for which this series is convergent, and the sum of the geometric series in this case for those values would be a, which is 1 over 1 minus r, which is x minus 2 over 3. To simplify it, let me multiply by 3 over 3. So I will have 3 minus x minus 2, and this would be 3 minus x plus 2, so it's 5 minus x. So this would be the sum of the series for those values of x in which this series, the geometric series, would be convergent. For other values of x, it is divergent. Here also I will write it as summation 2 over x all to the power n from 0 to infinity. So by comparing to this form, summation ARN, I find that A is 1 and R is 2 over X. So it is a geometric series and it would be convergent only if absolute value of R is less than 1. So distribute the absolute value. Absolute value of 2 is 2 over absolute value of x is less than 1. Multiply by absolute value of x. Notice that absolute value of x is positive, so I can multiply by it without any problem. So I will have absolute value of x is greater than 2. Now I have another kind of inequalities when absolute value of x is greater than d. The solution of this inequality is either x is less than negative d or x is greater than d. So I can write this as either x is less than negative 2 or x is greater than 2. So in fact, from negative infinity to negative 2, union from 2 to infinity, these are the values of x for which this series is convergent. And for those values, the sum would be 1, which is a, over 1 minus r, which is 2 over x. To simplify, multiply by x over x. So I get x over x minus 2. So these are the values of x. This is the sum uh, of the geometric series in that case. Uh, Thank you very much. Well, here, if you replace, yeah, n by 0, yeah, it's okay. N by 0, you get the first term, which is 1. So that's the end for those values. This is the sum. This is the end of this part of this section, and there will be another part soon.